Greetings, the Astro 30 here, yet again with a brand new video for you. And it's a bit cold here today, and that noise in the background you can hear, that whirring, is my fan heater. I apologise in advance if that becomes annoying to anyone. Today we're looking at this abomination of a power amp that failed to work better than an amplifier running on like 4.5 volts. We're only getting around about 1.6 volt out. Now, there was a guy in the comments on the last video who actually commented on my AEL50B design stage when he told me to remove that 470 picofarad capacitor off of the input to improve the frequency response. He was right then, and his comment yesterday on this particular amplifier was to change the 68K feedback resistor, for whatever you want to call it, to something higher, such as like 390K. I tried 270K and 470K and I wasn't getting any decent results out of it. However, he was right about the capacitor, and I believe he is right about that resistor. I'll tell you why. Now, I was searching online this morning and I happened to come across a variation on the same design. It's using exactly the same power amplifier, and this one's running on a lower voltage using a full wave rectifier with a center tap transformer. The transformer is rated at 48 volt AC center tap, so that's 24 volt. So at the end of the day, you've got 35 volts here as a supply rail, which is fine. However, he's changed the rating of this capacitor from 2200 microfarad 63 volt to 2200 microfarad 35 volt, which is pushing the limits of that capacitor. However, that's not what I'm interested in. What I'm interested in is what he's done here at the input stage. Number one, he's removed that half-wave point adjustable resistor. He's connected the feedback resistor directly to the output, so we've got DC feedback here. The value of that resistor is 470K. He's also got a 33K resistor here, which comes off the other side of the capacitor. So we've also got AC feedback biasing the base of this input stage, and he's removed that bypass resistor and capacitor off the emitter of the input stage. So all the other values are the same apart from this resistor here as part of the bootstrap. That's a 1K5 instead of a 2K2. That's probably due to the fact he's used different output transistors and different transistors here. They're not the same as the original design. So what I'm going to do is I'm going to do all the same modifications and see if by removing that adjuster and putting this AC feedback resistor in here, because also this resistor will give a discharge path for this output capacitor here to discharge through, so it's just basically going back into the input stage. So if this was not loaded, this capacitor wouldn't sit here charged all the time, and as soon as you connect the speaker you may hear a pop. That's because the capacitor's now got a path somewhere to discharge to. So anyway, I'm going to make those modifications and we'll see if we get better results. Alright, I've made the changes and I've got everything set up. Now it's either going to work better, or it's going to be no change, or it's not going to work at all. So what I need to do now is turn the power supply on. We do have an output, but I don't think it's any better because we're clipping bad. And we're producing full voltage. It's actually worse than it was before. We're now only pushing out 0.7 volts, 0.9, so yeah, something's not right here. I really am at a loss as to what's going on. Alright, let me fiddle with this a little bit more. Alright, I thought it might have been a power supply voltage issue, so I've now connected across the toroidal transformer on the positive and ground, so that gives me roughly 35 volt into the circuit. And with the same components, I'm barely getting 1.38 volt out before it clips. I reckon I'm going to have to rebuild that output stage. I don't think it's working properly, because I get less output when I change that BD139 back to the TIP41C. So I don't think these TIP41Cs and 42Cs respectively are good enough as output devices, not for power amplifiers anyway. Drivers maybe, but no, this is practically useless. Even at 35 volt, I should be getting a lot more out than 1.37 volt, whatever it is roughly peak to peak. That's ridiculous. Okay, so it's a few days later now, and I've been to JCar yet again, and I've got some additional components here. I've got a packet of these 1N 4004 diodes. It's a pack of 100, and it's ZR1005, and I use these all the time, and this is about $9 a pack of 100, so it's just cheaper to get 100 rather than a 4-pack, because it costs $1 for a 4-pack. So the amount of times that I've gone out and bought these diodes in a 4-pack over the last few months, which would be about 5 or 6 times, that's already $6, when I could have just bought a pack of 100 and had like probably 10 times as much. I've also got some BD139s and a BD140 plus a TIP36C. I've also got two 0.47 ohm 5 watt resistors there, just in case the 0.22s that I'm using in the output stage currently is also causing an issue, which I don't think it is. I've also got a trim pot in here, a 2K1, and another BD139 extra, just in case I want to actually build up that VBE multiplier. Now, having said that, the VBE multiplier is not the problem. That's not going to be causing our issue. It wouldn't matter if it was there or not. I reckon the issue is that the transistors just do not have enough gain that I'm using in the output stage to work effectively. So that means I'm going to build up or rebuild the output stage in Darlington configuration as it should be, and then try again. Okay, I've got everything rewired. Got 2 drivers, 2 output devices, 2 new diodes, and I've even replaced the BD139 here in the main voltage amplifier stage, just in case, you never know. So I'll turn it on. Now I apologise for the reflection on the oscilloscope screen, but we do have an output. Now if I increase it, we get a max of 2 volt peak to peak at clipping, which is still abysmal. However, if I disconnect this positive feedback, I want to call it the 33K resistor from the other side of the output from the circuit, boom, look at that. So let me just lower that. As we can see, it's pushing out now more like 14 volt, but it's got a bit of flat bottoming, so it's not quite biased correctly. And if we lower the voltage, we may see, yeah, look at that. We've got a bit of crossover distortion. Just a tiny, tiny bit of crossover distortion. So that is what crossover distortion looks like. So those 2 diodes are not quite biasing the circuit correctly. However, that can be adjusted by adjusting the resistors. I'm not worried about the crossover distortion at the moment. I'm more interested in this flat bottoming. Okay, that's a bit better. I put the 47K resistor from the base of the first transistor back to ground, and that seems to have corrected the weird flat bottoming we were getting. We still got crossover distortion, but that's alright. I'm going to say we're roughly putting out 11.5 volt peak to peak. Okay, so that's going to equal that when we divide it by 2. That equals that divided by 8. And it's 4 watts peak. As to what the RMS value was, it's 11.5 divided by 2 multiplied by 0.707. Okay, so multiply that by itself. 6525 equals that divided by 8, about 2 watts. So at 19 volt it's 2 watts. And at full power we're actually drawing about 240 mA. That's not even getting slightly warm. That one's fine. Let's get the hell out of me. That one's fine. That one's fine. Nothing's getting hot. However, we need to fix this crossover distortion that we can see here, because it's not perfect. Yeah, it's hard to get it. I pressed the wrong button. It's not easy to get a good. If I lower the frequency, we can see it even more pronounced. It's not easy to get a good trigger on this scope. Okay, got all the VBE multiplier components up here. So I'm going to turn this trim pot and see if we can get rid of that crossover distortion. That's actually making it worse, so that's the wrong way. This pot's wired backwards. Let's see, come on. As I turn the pot counterclockwise, the waveform is straightening out. Which is good. And I've totally lost the signal now. A wire broke. Alright, let me fix that and try again. Alright, so I'm going to try it with the multimeter. I've got 1 volt roughly across that 100 ohm resistor, which is roughly 10 mA. So I'm going to see if I can increase that by turning the pot. Yes, it does increase. But I think I've reached the maximum. It's not going any higher. So I might make it for a bias voltage of 10 mA and see if the signal's any cleaner. Looks pretty perfect to me. It looks like it's biased correctly and we're in the good sweet spot. So I'm quite happy with that, and we're still getting our 11.5 out. And you may think the waveform looks weird at that, but that's just the combination of input capacitor versus output capacitor. We seem to be having a drop off in voltage. But anyway, it looks okay. So I mean, for only 19 odd volts going into it, it's still pretty decent output. It's better than what I was getting. So that should be enough to drive any loudspeaker pretty loud. Right, what's the next step? I have absolutely bugger all idea. I might leave that running for 5 minutes at full power. It's only drawing 240 mA roughly. So go off and have a smoke, come back and make sure that this doesn't turn to smoke. Those resistors aren't even hot. This heatsink bracket or piece of aluminium is not even getting hot. neither is the load. I have to be careful of that. That negative side PNP transistor is not isolated, so I don't want that coming into contact with the case if I can avoid it. Alright, anyway, I'm going to go off and have a break for 5 minutes, and I'll come back and we'll continue. And 5 minutes later, it's still outputting fine. Nothing has exploded, and that's not even warm. All the configuration of the circuit should be right now. So what I'm going to do, it might be a good idea to power this on a higher voltage. So I'm going to use a 35 volt supply now. Got my donut set up with the electric danger noodle connected to it. Everything's connected to the supply, the negative's connected to ground, positive's connected to positive. So we're only using one side of the supply. I'll plug it in. And we do have an output. Don't know if it's going to go any higher though. Oh yeah, it'll go higher. So drop that down. Ooh. Sick of kicking stuff. Now we're getting some heat out of the heatsink too. Uh, 27 volts, roughly peak to peak. The bias current's probably going to be a little bit too high now, but I'll get to that in a minute. Okay, so 27 divided by 2, multiply by itself, divided by 8, 22 watts peak. So 27 divided by 2, multiplied by 0.707, multiply that by itself, 5445, divided by the load, easily 11 watts. Okay, it's getting there. I wouldn't say it's perfect, but that heatsink is now starting to dissipate some heat now, so it's actually doing some real work, which means our input sensitivity is probably a little bit higher now, but that's perfectly fine. What I'll do is I want to measure what the quiescent current is now. Right, well, as precarious as that looks on the desk, it's got a resistor now in series with the positive. So I'll plug it in and we'll have a look at the multimeter. That's probably a little high. That's 180 millivolts. So we need to drop that right down. Right, so the issue now is that's getting hot because the output stage is going into thermal runaway because the VBE multiplier is not connected to it. So I can't test it in this configuration for too long because it will overheat. Alright, I believe I found the biasing sweet spot. It's around 30 mA, which is about right. Okay, so I've got the multimeter set to current and I'm going in series with the positive rail, and my waveform is nice and clean. I want to see what its maximum current draw is. About 630 mA, which is not bad. It's quite small considering. I've also included a Zobel network on the DC side of the output just to maintain the amplifier's stability. Not that it's going into oscillation anyway, but it's remaining stable. But yeah, it's always a good practice to have one there. Our output seems okay. Alright, however, what I'm going to do now is I'm going to play with myself. No, I've already done that once today. Actually, no, I haven't. What I'll do is I'll hook this circuit up to the speaker and we will have a bit of a play around and see how it sounds, huh? Alright, speaker is connected. The oscilloscope oscillator is still connected. disconnect the multimeter out of circuit. The oscillator itself sounds weird into this, so what I'm going to do is I'm going to hook it up to a signal source now and see how it sounds normally. Okay, let's try some music now after I select what I want. What's this one?
My appetite.
That doesn't sound too bad actually, considering that the frequency response is all over the place on the breadboard, but yeah, it sounds alright. There might be a bit of a shushing sound there. There was a little bit of a mains buzz when it first turned on, but that's to be expected with how the circuit is configured. Now, would this circuit benefit from a long tail pair input stage? More than likely, yes, but it's extra components that are currently unnecessary for this to work. It is working as it should. It's producing around about the 10 watt mark into 8 ohms, which is okay, and that's at 35 volt. My final amplifier is going to be running at 42. So question is, what am I going to do with this? Well, I'll get to that in just a moment. Right, and there we have it there. So The differences are, well, I've re-included the VBE multiplier, of course. The feedback resistor, which was 68k, I've forgotten to indicate the 100 puff capacitor. I'll draw that in a minute. That's been replaced to a 470k instead of the 68k. The 4K7 that was here is now a 47k. And, well, we've got a Darlington output stage with the BD139 TIP35C and BD140 and TIP36C respectively. And we also have our Zobel network 10 ohm, 1 watt and 100N. Other than that, not much has changed. So I should really include this capacitor, which is easy enough to do. I'll just draw it in like that. There we go. Now it's complete. That's the revised schematic, and it seems to work okay in this configuration as it is, so I'm quite happy with the results. So it's a lot better than when I started. Anyway, this video is going on for 1,000 years, so it's probably a good idea to start cleaning up and finalise this video and finish up. So what am I going to do with this little circuit? Well, I'm going to design a PCB for it. And I'm going to split the PCB into 2 bits. I'm going to have the output stage, VBE multiplier and its adjustment points on one circuit board, and the actual drivers and input stage here on another, and the power supply components for it. And this is what I'm going to plan to do with it. I've got this horrible 1U rack case that I bought from J-Car several years ago, which was going to be used for my sub-bass processor project, but I've abandoned that now because, well, I don't need it for a start, and secondly, it's just a mess. So there's going to be some holes drilled in the bottom of the case here, as you can probably kind of see. They're going to be remaining permanent. There's not much I can do about it because they're on the bottom. But what I plan to do is a similar heatsink that I used for that bass buddy. I'll make 2 of them, and they'll be bolted to the bottom of the case with 2 toroidal transformers here in the middle. 15 ones should be enough because it's only drawing 600 mA, so that should be plenty of current from that little 20 VA toroidal. And make a little stereo test amp. Why not? The only issue I'm going to have is the larger profile capacitors are going to have to lay down on the boards because they can't stick up because, well, the case lid's in the way. So it's going to be a little bit of an effort on my part in routing a PCB. I want to try for single-sided. I mean, the VBE multiplier and output stage board would have to be double-sided so you can make use of the solder lugs or the pads on the top of the board, so it makes it easier when it's mounted down to actually solder the damn transistors. But yeah, that's later. It'll be a cheap project, and why not? And just have a little volume control, say here, and a power switch there. Bob's your auntie. And we've got a little test amplifier. I'll also include a muting relay in the output, so it's not making any weird turn on or turn off transients. And yeah, we'll go from there. But anyway, I'm going to leave this project here and this video here. But if you enjoyed it, please remember to go down below and rate, comment and subscribe if you haven't done so already. And yeah, we'll pick this up again in another video. But for now, I'm going to wish you a great day. And remember, by the end of August, I want to try and get to 2,000 subscribers so I can do a special Ask Me Anything episode of the Astro 30s Electronics Lab. Anyway, that's a little bit in the future. Anyway, this is the Astro saying see ya. Thanks for watching.